Hello, my construction squad. My name is Mark Britt. I'll be your instructor for this program. I have over 13 years of experience in the construction industry, and I am a licensed general engineer contractor through the California Contractor State License Board. After earning my license, I was honored to be selected for hands on training with one of the top construction companies in California, Turner Construction. A special thank you to People Working Together, PWT, for connecting me with this incredible opportunity. For those who may not be familiar with the construction industry, Turner Construction is behind some of the most iconic landmarks in California. They built the SoFi Stadium in Inglewood, California, the Levi Stadium for the 49ers, and right here in my hometown of Sacramento, they built the Golden One Center, home of the Sacramento Kings. And yes, Sacramento is the best city in California. Don't agree? Check the map. It's the only city in California with a star next to her name. All right, team. This is my idea on how I'm going to train all you guys at the same time for what you guys need to know to pass your contractor's license. If you're new to the construction industry, this course will help you get a head start. It'll boost your career, I guarantee it. So, team, we got about 13 chapters to go through. We're going to start this off with land survey, chapter one. It's going to get harder as we get into it. Just rock with me. We're going to make it happen. All right, chapter one, land survey. First step is knowing how to read a topographic map. A topographic map uses elevation contour lines that show the shape of the Earth's surface. These wavy lines on the map are called contour lines. When you think of contour, think of contour, the shape. Contour. Get it? Contour lines, okay? So the darker lines are called index lines, and they typically have a number on them. This number represents the height and elevation above or below sea level. So it's just telling you the level of that elevation. Could be in feet, could be in thousands of feet, depending on how the map is scaled. Okay. So the contour lines that bend upstream, they form a V shape. So when they're crossing a river, they're going to form a V shape to show you which direction that river is flowing. Okay. So the point of the V or U shape will be the source. So if it's coming down from the Sierra, it's coming through, American River to Sacramento River, that contour will be pointing up towards the Sierra, while the top of the shape, the V shape, the mouth of the shape will be pointing towards the source of where that river ends, i.e., probably a lake or ocean, wherever the river ends in the delta. Our Sacramento River goes into the delta, it goes down south from there. Okay, so the ring contour lines, when they be make circles, they're going to come in the rings. The rings going to get smaller. This is going to represent a mountain or a hill. So if you took like a Mount Shasta map and the mountain of Mount Shasta, the rings would get gradually smaller with the elevation going up tremendously. So there are some contour lines with hatch marks. These hatch marks, or hatchers, they could be called, are examples of craters. So these would be kind of like at the top of volcanoes or meteorite impact craters. It's going to show the indentation. Okay. All right. Chapter one, land survey. How to read a survey stake. So survey stakes are how we take our construction, engineering, architect plans, and we bring them to life in the field. So in the field, it's nothing but land. We did the topographic map, so we know our geography of the land. Now we're out there in the field. We use survey stakes. These survey stakes are typically 1 to 3 feet, 1 to 3 foot sticks that we write labels on to let everybody know what's going to happen in that area. So your limited disturbance stakes, those are typically found on the perimeter of the project, letting everybody know that the inside is a construction zone. Everything outside we're not touching that. It's not a part of this project. So if you look at this little picture I drew right here, it shows your typical cut and fill stake. So your cut stake will be the top one that says center line, CL. That's the logo for center line. So we're going to cut 2 feet right there to get to our desired elevation. And then your other stake is a fill stake. We got to raise the elevation over there by 2 feet. So we're going to fill in dirt for the fill stake, and then we're going to cut dirt for the cut stake. This type of lot would be a transition lot. We'll get to that when we get to grading. So basically, we'll cut that top off and fill it in over there to make it nice and level. All right. So your benchmark stake, that's your known elevation. It's always going to be your starting point. Remember that. Your benchmark is your starting point, always. And that's the symbol at the bottom of the screen for benchmark. It'll be on your construction plans. Then you have your station stakes, STA stakes. They're pretty much your coordinates. They're going to tell you how far your next site should be from that benchmark. Let's say 200 feet in this direction or 50 feet in that direction. It's your GPS coordinates to your map. It's your GPS coordinates to your construction map in real time. All right. All right. Chapter 1, land survey, calculate, cut, and fill. All right. We already did our topographic map. We got our construction plans. We staked out our area. We know everything's going to be on our construction site. All right. Next thing we need to do is we need to fill in our potholes and cut our hills down so that we have a nice level surface. All right. So to do that, we need to identify our benchmark. Remember I said benchmark is always the starting point. That's our known elevation. Please remember that. All right, we got to determine our points of interest. Our points of interest would be the high little hills and the low little dips. All right. Set up our transit. And we got to determine our height by taking readings. So when you set up your transit, you're going to put your transit in the middle. It's going to be in an equal distance from your turning point and your benchmark. For your benchmark and your turning point, you're going to have to put giant rulers, but they're called meter fiber rods, right? You're going to put one on your turning point. That's going to be the hill or the depression that we're going to fill in. And then you got one on your benchmark, and they got to be equal distances away. So first, we need to figure out the height of the instrument. So your foresight is a known number. Your foresight would be the number on the rod from your turning point. Okay? And your back sight will be the number on the rod from your benchmark. All right? So to obtain your turning point, your TP, and the height of the instrument, this is your formula. So your TP equals elevation benchmark plus back sight minus foresight. All right. And to get your height of your instrument, it's turning point plus back sight. All right. You got to remember that. All right, team, continuing with the first slide, use this formula to determine the elevation at each point. So at each point, we're already going to know our benchmark. That's our known location, our known elevation. Our back sight is going to be the number from our giant ruler that we have sitting on top of our benchmark. And our foresight, that's going to be the number that we have standing on top of our turning point. Okay. So to get our turning point elevation, so turning point elevation equals benchmark elevation plus back sight number minus foresight number. And then to get your height of your instrument, it's going to take your turning point plus your back sight number. All right. So for our elevation calculator right here, benchmark. Our benchmark elevation is 100 feet plus our backside number, which is 15, minus our foresight number, which is 22. That number equals 93 feet. So our turning point would be 93 feet. So now we have to take our turning point plus our backside to get the height of the instrument. So our turning point was 93, and we're going to plus 15 for our backside number, which gives us our 108 feet. So the height of our instrument is 108 feet. All right. So the next one is benchmark plus 50 feet. So our benchmark, and then we're moving to a different station, which is additional 50 feet in elevation. So our benchmark is 100 plus 50 feet. Okay. Plus 50 feet plus 17 feet for our backside number minus our foresight number, which is 25. Okay. So that number gives us 150. So our benchmark is 100 plus 50, 150 plus 17 minus 25, which gives us 142 feet. All right. So now we have to get our height of our instrument for that one. So our turning point was 142 feet plus 17 feet equals 159 feet. So our height of our instrument for that one, for station 100 plus 50, is 159 feet. See how we did that? All right, this is another little drawing, a little exercise I did to calculate our cut and fill. All right, so for our turning point 1, all right, the height of our instrument is 3 feet. The total reading is 8 feet. So our foresight says 8 feet. From our so that means to level it with our benchmark of our elevation that we wanted to do, we're going to minus the height of our instrument by our foresight, which gives us 5 feet. So our turning point would be 5 feet. We would have to fill that void in with 5 feet of soil so that it'd be level with the benchmark. Okay. All right, team, we made it through Land Survey Chapter 1. I truly appreciate you guys. Let's do an exercise to test your brain out. Question: a 2-story building that has 2,000 square feet of floor space per story is being demolished and will generate 40 pounds of debris per square foot of floor space. How many tons of debris will this project generate? And we're going to exclude the roof. It burnt off. So when you post just post your answer in the comments. That'll work. Thank you guys. I truly appreciate y'all. Y'all have a blessed one.